And welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 715, range module. Now, I tried making this video about a week ago and it was way too long and my explanation wasn't that great. So I deleted it and now I'm remaking the video. In the interest of time, I'm not going to read the question prompt this time because it's absolutely massive and it wastes time. So pause the video now so you can look at the question prompt because I'm just going to go jump right into an example. Okay, so hopefully you had a chance to read the question prompt. If not, go back and read it. Otherwise, let's look at an example. So we're going to be given our commands here. So the first one is to initialize range module. Then we want to add a range, remove a range, query a range, and a query a range. So the first one is just going to be to actually instantiate the object, so nothing to do there. And now we want to add a range. So the ranges that we're tracking, we're going to have it in a list, and we're going to be tracking basically from 10 to 20. Then the next thing we're asked to do is remove the range from 14 to 16. So remember that these ranges are not inclusive on the endpoint. So obviously 14 to 16 is inside of this range. So we need to modify it and basically split it up into two ranges here, right? So this needs to now become 10 to 14. Because remember 14 is not inclusive, and then everything, so we would go 16 to 20. We would have to split that up. So those are the new ranges after removing the range. So we've done that, we've done this. Now we want to query a range, and we want to query from 10 to 14. So obviously 10 to 14 is in one of our ranges. So from here, this query range should return true, pretty straightforward. The next query range is from 13 to 15. So obviously we have from 10 to 14 and then 16 to 20. So we don't have 15 in there. So obviously in this case we would return false because we don't have that range. So we would return false. And then the last query range is from 16 to 17, which we have because it falls in this range from 16 to 20. So here we would return true. So unfortunately, this problem is really easy if you're just looking at it. It's pretty easy to just build this and kind of draw it out. Unfortunately, putting it into code is a lot more complicated. So what we're going to do is we're actually going to break down each one of the three methods here that we have to implement, and we're going to think about how we're going to do them. And hopefully I won't take too much time because like I said, the last iteration of this was 36 minutes and that's just not acceptable. So enough talking, let's actually go and figure out how we're going to add a range. So we basically have to add a range, right? And let's just say we have a range of numbers. So we'll say like 1 to 3, we'll have, 5 to 6, and then we'll have like 7 to 12, right? So those are our ranges that we're currently tracking. And let's say we want to add the range from 6 to 9, right? So 6 to 9. So what we want to do here is essentially we want to insert this range into our existing ranges. And now there's two ways we could do this, right? We could do this in a linear solution where we basically just walk the array and basically figure out where to do it. And that would work. But one thing that you can actually notice here is that your input array will be sorted, right? Or sorry, the ranges that you're storing are sorted, right? Because they're increasing in time. And obviously, they're sorted based on the start time. So because they're sorted, you can actually use binary search here to insert this in log of n time, right? So it's going to take log of n time to basically find the position. But unfortunately, because we have a list here, inserting it is going to take big O of n time. So basically, we want a binary search for where we want to insert this into here. And then we're actually going to insert it. So logically, if we kind of look solely based on the starts, we would insert this and our array would look something like 1, 3, then we have 5, 6, and then we have 6, 9, and then we have 7, 12, right? We're solely inserting based on that first start time, and we're not really caring about this end here. So this is where we would insert it, and this is correct. But the problem here is that now we have intervals that overlap, and because of this, we need to now merge it down. So this problem that we need to do now actually is the same thing as a Leetcode problem, and it's called merge intervals, right? if you remember this, and I have a video on how to do this on my channel, you can find it. We're just going to merge this down and basically, take care of all of these overlaps. And we can actually do that in big O of n time. So to summarize what we're gonna do here, the first thing, we need to find and insert, right? Find and insert, which is gonna take big O of n plus log n time, right? Log n to find where we need to insert, and then insert it in big O of n time because it's a list. And then what we need to do is actually merge the intervals once we've inserted it, because obviously now there are intervals which are not complete, right? These really should be joined together, and then this one can be joined together as well. So we would need to do that. So we need to merge them, and that's going to take big O of n time. So that is how we do add range. Pretty straightforward. Basically just do your binary search, insert it, and then merge the intervals down. So that is the approach we want to use for add range. Now let's think about what happens when we actually want to remove a range. Now let's think about how we actually want to remove a range. So in this case, there's actually 4 possible paths that we could take. So let's go through them one by one. So the first case is where the range is actually greater than an interval, right? So what we're gonna do is we're actually gonna go over our intervals from left to right and check which ones we need to remove. But let's say a range is from 1 to 10 that we wanna remove, right? So we're told to remove the range from 1 to 10, but we get an interval that's like 1 to 5. So obviously 1 to 10 swallows this entire interval, right? It engulfs it entirely. So in this case, we just want to remove this interval because obviously it's inside of the big range here. So we just get rid of the entire interval from our list of intervals. So that is case 1. And what we do here, like I said, is just remove the interval, right? Simple enough. So the second case is there's actually no overlap, right? So sorry for the ambulance in the background. Basically, say we're asked to remove the range 1 to 10, but the current interval that we're working with is actually like 15 to 25. Obviously, there's absolutely no overlap here, so we just ignore this interval because there's nothing we can do here, right? There's nothing for us to remove. So if there's no overlap, we just ignore the current interval that we're processing. So ignore interval. Okay, cool. So that one's done, this one's done. So the third case is that there is overlap. So overlap on the left or the right boundary, right? So we could have like an interval. So we're asked to remove the range 1 to 6, but then we have a range from like 2 to 7. So obviously there's going to be overlap here. So in this case, we just want to modify the interval and get rid of what we need to get rid of, right? So, we would get rid of, if we need to get rid of 1 to 6, well, then we would get rid of basically 2 to 6, right? So we would just leave 7. So we just need to remove what we need to remove and then just return the original interval. So that's what we're going to do. So we're just going to modify the interval. Hopefully you guys can read that. So we modified the interval. And then the last case is that basically the interval is actually greater than the range. So for example, if we have an interval who's tracking basically 1 to 100, and we're asked to remove the range from 1, let's just say, 15 to 20, obviously this is inside of this range. And what we need to do is actually break it up into 2. So we want to have the interval from 1 up until 15, because remember, it's not inclusive on the left side. And then we want basically from 21 up until 100, right? So actually it should be 20 because this interval isn't inclusive on the end either. So basically we split it into 2 in that case. So if our current interval is so large that it basically engulfs the entirety of the range we want to remove, then we just we have to split our interval into 2. So split interval, right? So those are your 4 cases for actually removing. Let's go through them. So if the range is actually greater than the interval, then we want to remove the interval. If there's no overlap at all, then we just ignore the interval. If there's an overlap somewhere on the left side or the right side, we modify the interval and chop whatever we need to. And if the interval is actually greater than the entire range, then what we want to do here is just split the interval in two, and there you go. So those are your 4 cases when you actually want to remove a range. And remember, we're going to have our intervals list. So intervals, this will be some list of, 1 to 2, blah, 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 right? These will be the intervals. And we're basically just going to go over the entire list in one pass and basically check, do we need to remove something? Do we need to edit something? That kind of stuff. So we're just going to go through one time and basically check all these cases for all of the intervals. So that is remove range. Now let's do the final one, which is to actually query a range. Okay, so now we just need to talk about query range. So let's say we have some intervals, right? So we have -1 to 0, 1 to 2, 3 to 5, right? So say we wanted to basically figure out if we have the range from 3 to 4. So what we can do is we can actually employ a binary search here to find out which is the interval that will actually contain our range, or at least contain the information as to whether or not we have our range. So what we want to do here is basically binary search, and what we're searching for is the interval whose start is as large as possible, but also satisfying start is less than or equal to whatever this left value is, right? And obviously this makes sense, right? Start can't be greater than left, because then we wouldn't even have the interval, right? If we found a value where start was greater than the left starting point of our interval, then obviously it doesn't contain that start point. So we want to find the interval whose start value here on the left is as large as possible, but also satisfying this result. So we want it as large as possible to give us the best chance of actually finding the one that might contain it, right? If we got a smaller one, it might not be the full range that we want. So we want to basically find the largest start here within our intervals that also satisfies this property. So we can actually do this because it's a binary search. We can do it in log n time. So once we find the interval, which will be this 3, 5 here, then we can simply check, because we know that start is actually less than or equal to left. We know that obviously the left point will be contained within that interval, right? By definition, if start is less than or equal to this left value, then it's always going to contain it, right? If start was like 1, then it's always going to contain 3. If it's 2, same thing, and then 3, it has 3, right? So that's fine. So start, we know it's all right because we have our binary search set up this way. Now all we need to do is actually check the right endpoint. So if we have a value here, if we were able to actually find an interval here, then what we're gonna do is simply check that right. So we basically just want to double check that basically that right value is greater than or equal to the right value we're looking for. If it is, then we're good to go. If it's not, then obviously we don't contain the right and we don't have this entire range. So that's what we want to do. Like I said, we do a binary search to figure out the interval that actually contains the information we want, and then we'll actually check the value inside of there to make sure that we actually have that right, because the left we will find through the binary search. So that is how you want to do query range. Now let's actually go into the code editor and type this up. This is a pretty large problem. It's really hard to explain. And for this reason, I'm actually just going to use some of the Python bisection methods, because trying to implement the binary search and doing this all in an interview is going to take way too much time. It's way too hard to explain, and you're definitely going to fuck something up. And it's much easier to just use those tools. If they force you to use your own binary search, good luck. Pray to whatever god that you worship, because you're definitely going to need some sort of blessing. Otherwise, for this video, we're just going to use the Python built-in binary search function. So I will see you in the editor. Let's stop taking up time. All right, we're back in the code editor. Let's write the code. So the first thing that we need to do is just define the init function, and we're just going to be storing everything in a list. So we're going to say self.intervals, and this is just going to be an empty list. Unfortunately, I don't have the 200 IQ required to understand the segment tree solution, so we're going to have to do it with the list solution. So let's implement add range here. The first thing that we want to do is remember, to add a range, we need to find the position where we need to insert it. So luckily, in Python, we can actually say bisect.insort, which is basically going to insert in sorted order some value into a sorted container. So we obviously have a list of sorted time ranges, and we're just inserting something into it. So that will find the position it needs to insert it, and it will put it there for us. So we're going to insert that into self.intervals, and obviously we're inserting the interval from left to right. So now that we've done that, remember that we need to apply the merge intervals formula here to actually merge down the intervals, because it could be the case that we inserted something, but there's overlaps that we need to take care of. So remember that the formula for this was basically just to say res, and then we just take it intervals of 0 as our starting point, and then we're just going to try to merge as much as we can. So we're going to say for I in range len self dot intervals. What we're going to do is remember we get the current interval, so we're going to say interval equals what? Self dot intervals of I. And then remember, if there's an overlap, we need to take care of that. If there's not, then we just add the interval into our results. So let's check if there's an overlap. So we're going to say if res, so if the last interval, its endpoint actually is greater than or equal to interval of 0, so the start of our previous, of the current interval, then what we need to do is we need to change the ending of the last interval to adjust it. So we're going to set it to the maximum of the interval -1. Oh, sorry, this should be res. Why did I say ret? That's weird. So res here, -1, 1, and it's going to be the maximum of interval 1. So this really shouldn't be anything new for you guys. Probably you've solved merged intervals before. If you haven't, I have a video on it. Go watch it if this algorithm doesn't make sense, because I'm not really going to be explaining it here. Otherwise, if there's no overlap, then remember that we just add the interval to res.append our interval, right? Cool. So at this point, we have actually merged everything down, and it should be back in the quote unquote stable state. So we're going to say self.intervals, and then we're just going to assign this to the res. And that's all we need to do here, because obviously we don't return anything from add range. Okay, so let's now do remove range. And remember, what we do here is we're going to go from left to right over our intervals. And what we're going to do is basically we're going to, if we need to remove an interval, if we need to add an interval, if we need to break one up or modify it, we're going to do that. And then we're going to add it back to a list, and then just reset that self.intervals with that list that we have, because we don't want to do it in place because it's a pain in the ass. So again, we're going to say res is going to be an empty list, and we're going to say for interval in intervals, self.intervals. What we want to do is, remember the first case is if the range contains the entire interval. That means that we just want to ignore that interval. We can just basically get rid of it. So we're going to say if left is less than or equal to interval 0. So basically, if the start of our removal range is, before our current ranges start, our current intervals start, and the right is actually after the interval's endpoint, then we just ignore this range, right? We're not going to add it back to our list because there's nothing for us to do here. We just want to ignore it because we won't be adding it. So the second case is the one where there's no overlap at all. So we just want to add that interval back into res. So let's just check if there's any interval. So if the left is actually greater than the end of our interval, or the right. So basically the right is, before the start of our interval, then obviously there's no overlap. So we simply say res.append. So we just want to append the current interval. Cool. So next case is if there is an overlap. So we'll handle them both the same. So if there's an overlap, so if left is actually less than interval of 0. So in this case, now there's going to be an overlap here. So we want to just say res.append. So we want to be going from the right up until interval 1. So this is going to be the first overlap that we can have. And then the other overlap is if right is actually greater than the end point of our interval. Then what we want to do here is we basically just want to chop from the right side. So we're going to say res.append, so basically from the start of the interval up until the left point of the intervals of the range that we were given is what we want to keep. So the last case here, remember, is where the interval actually covers the entire range, in which case we just need to split that interval and by removing the range itself. So we're going to do that by saying res.append. So we're going to append the first half, which remember goes from interval, so the start of our interval, up until the left point of the removal range. And then we're also going to go from the right point of the removal range up until the end of our interval. And those are our 4 cases. So once we do that, all we need to do is say self.interval. So we're just going to reset it to our result here, and then we are good to go. So we have now handled all 4 cases. Now the last thing for us to do is simply do the query range. So for query range, remember that we use a binary search to basically find the position where we want to insert our interval. And basically what we're going to do here, so we're going to find that index, and we're going to say bisect dot bisect, and we're going to pass the intervals, obviously intervals, and then we're going to pass the left. And then for the actual right side, we don't care what it is. So for this part, in order for us not to get any wrong answers here, due to edge cases, we're actually going to set the right to be the largest possible value that we can have in here, which is actually I think 10 to the 9th if you look at the actual problem description. And the reason we do this is because when Python actually does the comparisons inside of the bisect function, so when you do your comparison inside of your binary search, if you know how lists work for the comparisons, essentially this is the reason why. I'm not going to go too much into detail. Essentially this is just to capture a certain edge case, and we want to avoid it. So we will basically find the index where we want to insert it, and bisect actually gives you the index. It's basically a bisect right, so it would actually give you the index to the right of where you want the interval that you want. So we actually need to do 1 minus whatever index this receives, but we need to actually make sure of a few things first. So the first thing we want to do is, obviously, if there are no intervals, then there's nothing for us to query. So therefore, we can't return anything. Or if the index returned is actually 0, then obviously, since it's a bisect right, that means that there's literally nothing in front of it. So therefore, it's not possible for us to actually contain this range, because there's no intervals before it for us to actually compare. So in this case, we're actually going to return false. And remember that bisect, but under the hood, is actually a bisect right. So it will actually give us the index that we're looking for, but +1, because that's where it would insert it if it was going to insert it. So if you want to read the documentation on how bisect works, it might be good for the actual interview, but it essentially gives you the index to the right of what you're looking for. Because bisect is actually just an alias for bisect right if you look in the actual source files for the bisect module. Anyway, once we have that, remember that now we're guaranteed that the left point is actually okay, because remember, we're looking for basically the point such that the start of our interval is less than or equal to left. And obviously this makes sense, because if we had a start of our interval with 1, obviously that is going to be less than 3. So that's fine, right? If we had something like 4, that's never going to contain 3. So with 1, it's not guaranteed that it contains 3, because it could just be an interval from 1 to 2, which is why now we actually need to check the right endpoint. So we're going to say return self.intervals of whatever that index. Remember, it's -1. And this is also why we need to check that if index is 0, obviously index -1 would actually check the end of the array, because that's how Python reverse indexing works, which we don't want to do here. So we want to check that previous index and the first value, which is the end point of the interval. As long as it's greater than or equal to the right, we're good to go, and we can return true here, or we're going to return false if that's not the case. So that is actually the code here. Like I said, I mean, it's relatively straightforward code-wise, but just there's so many moving parts, and especially with these bisects here, which just make it an absolute pain in the ass, especially if you had to implement this yourself. Geez, that is brutal. Anyway, so now let's actually run this, make sure I didn't make any syntax mistake. Yeah, self.intervals. Okay, yeah, that's why I run it. Range. Yeah, self.intervals. Okay, run. Okay, it looks like we're fine. Let's submit this, please. List.append. Ugh. Open brackets. Yeah, okay. Well, sometimes we make mistakes. I'm only human. All right, submit this. And all right, cool, accepted. So thank God, because I did not want to re-record this. So all right, so we already talked about the time complexities when we actually did the diagrams, but we'll just go over it again. So add range, obviously doing an insort here. The actual finding of the insertion point is going to take log n time because it's a binary search, but because we're using a standard list here, obviously inserting into any random index in a list is going to cost big O of n time, and then the merge intervals formula or algorithm basically takes big O of n. So this one asymptotically is just going to be big O of n. Now, if you did use a sorted list data structure, you could get this down a bit, but then again, you'd still have to merge it, so you're still going to get O of n on that, so it's not too big of a deal. Space complexity wise here, it is going to essentially be big O of n, and the reason for this is, well, for one, when you do the insertion, that costs big O of n, and then also for the actual building of this res here, which is essentially going to be dependent on how big the original intervals was, so that's going to be big O of n. So query range, this one is relatively simple. Time complexity wise, all we're doing here is a binary search, so this one's actually going to run in log n time, so pretty straightforward there. And then the space complexity here, this one is going to be big O of 1, because all we do is a binary search and we don't create any extra space. So that one, log n on the time, space is going to be big O of 1. So for remove range, we essentially have in the time complexity, obviously we have to go through all of the intervals. So that's just going to be big O of n. And then for the space, it's also going to be big O of n, because we're basically creating this temporary variable to store all of the intervals as we, process all 4 cases. And then you just put, so it's big O of n. So yeah, that is how you solve a range module. Like I said, the first video took way too long. I don't think I explained it that well. Even this one is quite hard to explain. I think if anywhere I am a little bit fuzzy on is this query range part. I understand how it works in my head. Hopefully the explanation with the bisect made sense. This is the one part where you might want to do a little bit of extra research on your own. But I mean, the code's all there. As you see, it gets accepted. This is the runtime complexity. So hopefully it at least steers you in the right direction. Like I said, this is a fucking hard problem. It took me a lot of time and pulling my hair out trying to figure this one out. And this is the best solution I could do. I mean, there is a segment tree that's like the most optimal, but honestly, if you get asked that to implement it, the interviewer must think you're some sort of Leetcode god, because you're not coming up with this on your own. Like, this is pretty straightforward. Like, you could maybe come up with this in an interview and it's pretty easy to remember, but segment trees, unless you're literal like competitive programming god, then you're not coming up with that. Anyway, I don't want this video to get too long, so if you enjoyed this, leave a like and a comment. It really helps me out with the YouTube algorithm. Subscribe to the channel to help me grow, and if you want to join the Discord community where we talk about all things FAANG, interviewing, systems design, resume reviews, referrals, all that stuff, join the Discord, link in the description below. Otherwise, thank you so much for watching, and I am out of here. Bye.